Assalamu alaikum warahmatullahi wabarakatuh. Hello everyone. Today I'll be explaining the paper entitled as Product Mix Optimization Scenarios, a case study for decision support using linear programming approach. This paper is a good practice for students who are studying operations research and optimization for the first time and want to use simple methods to understand operations research in addition to having some kind of innovation that enables them to publish a conference paper in the field of operations research. The product mix problem is a widely studied type of problems in operations research. However, every day more research is out there studying product mix problems. Why is that? Because each company has its unique challenges that makes the product mix problem different from one company to another. Of course, the general product mix problem definition is that we are aiming to know how many to produce of each type of product that the company is producing in order to maximize the profit. And of course, each company has its own constraints, its own production facility, its own regulations, and this actually creates some uniqueness in this type of problem. The problem that we are studying today is soft product mix problem, and we need to differentiate between soft and hard product mix problems. A soft product mix problem is when I have different resources are used for the production of all the products or some of the products that I have. A hard product mix problem is when like I'm producing really different types of products. For example, you are producing cars and bicycles, so the materials or the parts that are used to produce cars are different than the bicycles. So this is a hard product mix problem, but today we are using or we are studying soft product mix problem. Okay. So the paper here introduces some scenarios that we need to take our decision based on these scenarios. Let's jump to the problem statement. And we have here a company called X is a bird for food packages producer. So it produces packages of food for birds, some types of birds. It blends seeds, different seeds, in order to have different packages. So these packages are depending on studied percentages to improve birds' health and so on. So the company produces 6 types of products. 3 of them is for budgie birds, 2 for canary, and 1 for zebra. We are not interested in that. We just want to know that it produces 6 types of products. So we have our set of products from 1 to 6, and the company purchases 27 types of raw materials every month. Okay, so I have sets of product that is 6, and I have the set of raw materials that equals to 27. All right. The amounts of purchased from every resource depends on the degree of economies of scale required. Different mixes of seeds are used to produce different products with different amounts. All right. So we have here this table show us the raw material name, and we have here the quantity in grams used for producing this product. So for each product we have a table like in this format. Okay, it requires this type of raw material and this amount of quantity of the quantity needed of this raw material. So we add that up and we have our product, and that's good. Okay. Food required for of budgie birds is always changing as something. This is something related to the bird itself. some materials contain some packages contains 19 feeding items, so each product has different amount of raw materials used or different raw materials used, but overall the 27 raw materials are used for the 6 products. I want to jump for the objective. Okay, the primary objective of this study is to determine how many of each product should be produced to maximize the profit and what is the corresponding utilization of resources. Okay, so taking into account the utilization of these resources up to this point in time when this paper was published, it wasn't considered before, and this is considered type of it's very small contribution. Okay, it's a very small contribution. I admit that, but it is a contribution, and this is something that you need to take in mind when you are making a research paper. You should have any type of contribution. This is not the only contribution that we have. Just bear with me and you will understand what I'm saying. Now we go for the mathematical modeling. Okay, we have here, let I represent the name of product. So product 1 is when I equal 1, we are talking about product 1. Then PI is the selling price for a package of product I. So PI is the price of product 1, or one package of product 1. So we have here the first package of product 1 is sold with 20 Egyptian pound. The second type of product is sold for 25 and so on. Okay. All right. And let J to be the number of raw material or seeds supplied monthly. Okay, so J is the raw material and I is the product. So let WJ is the weight in kilogram of supplied raw material J. So WJ is amount of supplied raw material in kilogram for raw material J. CJ is the cost per kilogram. How much do I pay to buy this raw material J? All right, and there is an example. C10, for example, is 14.2. This is the cost of buying 1 kilogram of raw material 10. So this is the cost C10. Okay, and we have J then here. It's between 1 and 27. This is the set of raw materials. And what about our decision variables? Our decision variable here is xi, is the number of packages to be produced of product I in order to maximize the profit. So x1, this is the number of packages to be produced of product 1. All right, until now we are talking about normal product mix problem. Okay. And we have here the constraints, non-negativity constraints. My product must be greater than or equal to 0. Integrality constraint, like xi must be integer, the number of products must be integer. Raw material capacity constraints, the raw materials, the amount of raw materials used in the production must be less than the raw materials supplied on monthly basis. So Yij is the amount of seeds or amount of raw material J consumed in manufacturing one package of product I. So let's say I need 10 grams of a specific raw material in order to produce one package of the first product. So this is the amount we say Yij. So first product, first raw material, then this is Y11, the amount needed for the first raw material, and so on. This is multiplied by the quantity that I'm producing of this product. So if I need 10 grams of raw material 1 to produce one package of product 1, so if I produce 10 packages, I will multiply this 10 gram by 10, the number of packages that I'm producing. So the total raw material needed of this raw material would be 100 grams. 100 grams used to produce 10 packages. Okay, so this is the thing here. I do that and I sum all of that for all the raw materials and all the products I'm producing, and this amount for each raw material must not exceed the amount that I'm buying of this raw material. So the total amount used to producing all the packages must be less than the number or the amount I have. This is a capacity, we call it a capacity constraint. We will explain that in more detail in Excel. And we have, of course, the objective function. We want to maximize the revenue. We assume that everything is sold produced is sold. So summation of price multiplied by the quantity of each product. We need to sum all of that, and of course, the total revenue minus the total cost give us the profit. So we can here maximize the profit or maximize the revenue. It's better, of course, to maximize the profit itself. And we have here, okay, WJ, CJ, this is the cost of raw material J. So I sum that for all raw materials from from J equal 1 to 27. This is a mistake. This should be J. All right, so here is the amount of raw materials. I receive 900 kilograms of the first one, and the price per kilogram is 13.2 Egyptian pound. The 2 here, this 0.2, I think it's for transportation as far as I remember, and so on. Okay, so these are the raw materials, and this is the initial result. We will formulate the problem right now on Excel, but just let's look at the initial results here. We will have that some products we are not producing of them at all, maybe just one package here, one zero package there, zero here, and this actually caused a problem in the company. Also, let's look at the utilization of resources. Some resources are consumed 100% and some resources are like, I'm wasting a lot of resources here. The utilization is the amount of raw materials that I use over the total amount that is available. And when these raw materials are consumed, they make me stop the production process because these raw materials are consumed. I'm not able to produce any more packages without these raw materials. Okay, so this is actually a problem that we will need to solve. But now let's go for the Excel formulation and let's continue. All right, so let's see what we have here. We have here the product names. We have 6 products. Assume there's 1, 2, 3, 4, 5, 6. And we have here the selling price for each product. And here we will have our decision variables. These are the number of packages to be produced of product 1. Here the number of packages produced of product 2, and so on until the number of packages produced of product number 6. Here we have the supplied raw materials in kilograms, as we said before, per month, of course. And here we have the amount of raw material needed to produce one package of each product. So for example, for this raw material, canary seeds, I need 130 grams to produce one package of this budgie product, and I need 240 grams to produce one package of the second product, and so on. So how about the consumed material? How much do I consume if I want to know how much materials I need to I would have, how much I'll consume when producing just one package of each product. So we will have this amount here, raw material, multiplied by the number of produced packages plus this multiplied by that. This is for the second, plus this for the third. This is for the fourth, and we do that for the last two. Okay, and I will tell you about easier process how to do that, but I just wanted to explain it in the very simple terms. So 130 multiplied by the number of packages I would produce of the first product plus 240 multiplied by the number of packages produced of the second product and so on. This will give me what? Will give me the total amount of raw material one used to produce these products. So let's put here one, 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 and one. Okay, so I will need 1375 grams of canary seeds in order to produce one package of each raw material. So if I put this zero, what happens? This is the amount to produce one package of these raw materials, excluding of course the first I didn't produce and so on. So the consumption here, we can just remove that and I put something called some product. Okay, and I put that and comma, I put that array, and that's it. So I will have the same result. Okay, so this is the amount of raw materials consumed to produce just one package of these. So what are these? What is this? What is this 270? Let's say 1, 2, 3, 4. So this is the fourth raw material, and this is the amount needed from the fourth raw material in order to produce one package of the third product. So what does this called? Like we called it something before. We said Yij. Yij is the amount of raw material J, which here is the fourth raw material, needed to produce one package of product I, and we have here this product is product 3. So this is Y 3, 4. So the amount of raw material 4 needed to produce one package of raw material 3. And each one of these, this is the matrix, this is the raw material matrix, this is the resources needed to produce these packages. And this is really important to understand for the compact format. Okay. All right, so how about these? These are the maximum amount of raw materials that I can be consumed. Like here, okay, we actually need to, here we like divide by 1000 in order to get it in kilograms. So we consume here 1.3 kilograms to produce just one package. This number consumed must be less than or equal to the number or the amount of raw materials that I have monthly. So this number cannot exceed 900 and this cannot exceed 650 and so on. All right. So this is the amount of consumed must be less than or equal to the amount I have. This is what we call the capacity constraints. Okay. The utilization is simply the amount consumed over the amount that supplied. So how much did I use of this raw material? Okay, and I have here the prices. So this is PJ or CJ, the cost. This is the cost of raw material, CJ. So this is C1, C2, and so on. And yeah, this is actually the problem that I have. Now, what do I need to calculate? I need to calculate the objective function. I have here the objective function, which is the sum product. The objective function here is to maximize the revenue. Okay, let's assume that we are maximizing the revenue. So I just multiply the number of products with the sales price. So the more convincing or the better thing to consider is not the revenue but the profit. But here let's assume, okay, the paper as is, like we are considering the revenue. So I just multiply the decision variables that I have, the number I would be producing, multiplied by the prices. Okay, and that's it for the objective function. All right, so the problem now becomes so easy. Let's have here the material cost. The material cost, of course, is okay. What is the material cost? I will multiply this price multiplied by the amount of raw materials that I will be considering. Okay, no, this is actually another paper, sorry. So I just multiply the price per kilogram multiplied by the amount of raw material. So the material cost is something that we consider fixed for this paper. I will explain another paper that is an extension of this one, and things will be actually different. And even in this paper, yani just in this step, this is the raw material that we have. Okay. So I just, for the profit, I just have the sales or the revenue minus the raw materials. I will get the profit. And for the overall utilization, we have here sum of that over sum of that. This is the overall utilization, and this is the cost per product. So I just divide the cost over the raw materials over the total number of products to be produced. Okay, all right. So that's fair. So let's go for data and go for the solver. And for the solver, I put here O2. This is the objective function here, and it's a maximization. And by changing, I will change what? I will change the raw materials here. I will change these cells. Okay, and I need them to be integer, and I need the raw materials to be used must be less than the raw materials supplied. Really simple problem, and here I use simplex solve, and this is the solution that we got in the paper. Okay, and we see that there is a problem with that. But let's have here a look at the utilization. Some of the raw materials are almost 100% consumed. We have here this 899 kilograms and supplied 900, so it's 100%. So I have 4 raw materials that are consumed. These raw materials consumed, we call them capacity constraint resources. So I will not be able to produce just one more package without these raw materials. So they are done. I can't have anymore. I also have 0% utilization of some raw materials. For example, the wheat here is 0. Why? Because it's only used for the last product. I have 0 of that. So I bought this raw material. It cost me 204 Egyptian pound, and I didn't use them at all. Others have 7% and so on. So this is a problem for the company. We went back to the company and asked them, is this okay? This is a solution that maximizes your profit or maximizes your utilization? Also, overall utilization is really not really good. And the answer was no, this is bad. We need to have some more constraints. And let's look at these new constraints in the paper. So initial feedback here. So for the company management team, it was unacceptable for them not to produce these products. In addition, the utilization percentages needed to be above 90%, the overall utilization. Therefore, new constraint is added, new constraints actually, because these are multiple constraints, that each product must be, the number of products produced must be greater than 600 and less than 5,000. This is according to like production plan or demand or whatever. And also we need the percentage here for the utilization be 90%. So how we do that? How we do that? Is it as easy as it seems, or what? If we impose a constraint that we need to have a 90% utilization of raw materials, this means that the raw materials themselves are becoming also a constraint. Okay? In addition to that, we were told that the raw materials are bought in bulks. Like I cannot buy whatever amount that I need. It will be more expensive. So for economies of scale, they can only buy multiples of the initial raw materials. So If I'm buying 900, I can buy 900 multiplied by 2, 3, 4, 5, multiplied by any integer number. I cannot buy like 450 of this raw material in order to satisfy my demand, and this is another aspect of the problem. If we consider this in the formulation, normally we will end out or end up with a nonlinear problem. And actually, someone who's taking operations research for the first time, I'm not familiar with nonlinear, and it would probably take much time to solve or something. So we needed something or a clever way to get around that. And actually, this is done in operations research all the time. When you have nonlinear problem, you try to figure something out to make the problem linear and yet solve it, either by linearization methods or coming with this solution that we came out with. Um that I will just let you know about that right now. So let's get back to our file here. So how to solve this problem? Actually, we see for the capacity constraint here, these four capacity constraints, and we actually multiply them by 2. So let's just say this is equals this, and we just multiply it by 2, and this one, and this one, and finally here this one. Okay, so here we are saying that we will provide more of this raw material, and it abides to the multiplication rule. Okay, and for the products here, we add a constraint that these products must be greater than or equal 600, and they should be less than or equal to 5,000. And we click OK, and we solve the problem. Let's add that the utilization here must be greater than or equal to 0.9. Just let's give it a try and try to solve the problem. Okay, solver couldn't find a feasible solution. So this is something that we faced. So all right, so let's remove that constraint, okay, and solve the problem. Okay, we have an answer. Okay, so we have here these amounts to be produced, and we have the utilization here is 84%, and actually the profit is with the minus, but we have an answer here. All right, so again we search for the constraint that is causing the problems, and we just get more of that in order to produce more and more. So we multiply that by 2, and is there anything 100%? No. Okay, and you just solve the problem again. Okay, and we have here 75%. We have a positive profit, and we have here the amounts are within the constraints that we want to have, and but the utilization is less than 90%. So we keep doing this until we have the utilization above 90%. So let's get back to the paper, and actually we have here yeah, we have here all the trials summed up here, summarized here. So this is the first trial, and the second, third, and so on, until we reached 93% at the 10th trial. There is another way to do this, and I will ask you to think about it if there is another way around to do something like this. It was a good paper, a good innovation for an undergraduate student. And yeah, we satisfied all the demand and everything, and we have here the raw material costs also increased, not dramatically, while the revenue increased much, and also the profit increased much compared to the original case. And yes, also we have here an output like having more raw materials or like using this situation or this methodology doesn't also always guarantee more profit or or improvement, because here we have a negative profit here in this case where the cost was higher than the revenue uh, income for the company. All right, so this is the paper for today. It's really straightforward. The method is innovative. It's a good contribution. So in order to publish a paper, just an insight, you need to have an innovative solution for a hard problem. You need to have something new, a new constraints. You can get any research paper from the internet and just add some constraints to it and test how this is going, and it could have a potential to be published in a conference paper. I'm not saying a journal because this is not a big contribution. Like you are not adding much to science. Conference papers, after all, are kind of proof concepts or ideas to discuss with colleagues in the scientific community. However, journal papers, they go extensive review process, and they need to have a big contribution in order to be accepted in a good journal, Q1 or Q2, or having journal having a good impact factor. I hope you like the paper or like the session today, and I wish to hear your comments and have a discussion if you are willing. And see you next time, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.